Welcome to another NUCIDA video. If you like it, please give this video a thumbs up, subscribe to this channel, and click the bell. Never forget our upcoming sessions. If you have any questions or hints, please leave a comment. Our certified QA experts will reply in time. It's never been easier to manage tests at scale than with Xray Test Management. Xray is a Jira native software test management app that ensures your testing and development teams are collaborating to achieve the highest quality products. With Xray, you'll never deliver broken or untested code again. Xray is a comprehensive test management solution that uses Jira native issue types to specify, organize, plan, and execute tests. With Xray, you can create your tests and add preconditions, organize them using the test sets or the test repository, plan your test strategy, and finally execute tests and report the status. In this video, let's explore why test parameterization is important. So, when testing applications, and especially large systems, teams often face the challenge of managing many test scenarios. These tests can become repetitive, taking up valuable time and your resources. With test parameterization, we can efficiently run the same test logic with different inputs and significantly reduce the complexity and duplication of test cases. Starting from a more strategic level, we are going to briefly talk about data-driven testing, or DDT. It is a software testing technique with several stages, including parameterization, execution, and reporting. Without that technique, if you have a workflow with dynamic but repetitive elements like a card checkout, you need to manually create each iteration as a separate test case from the quality standpoint. That approach often results in a very fragmented view of the system and struggles with redundancies or omissions, which significantly increase defects and risks in production. From a speed standpoint, manual, isolated creation and maintenance cannot keep up with the modern market demands. With DDT, only one test entity is needed with a data table attached to it. Then you will be able to run your test multiple times for each entry on such a table. Today, we focus on the parameterization stage. Specifically, it consists of two parts: inserting parameters in the script and forming the data table. The stage belongs more to the test design realm and prioritizes the theoretical aspects of risks and necessary data coverage. That doesn't mean you can completely ignore the execution restrictions, though. As a quick example here, an authentication test could have been written 3 times separately with different usernames, passwords, and resulting messages. Instead, dynamic elements are replaced with parameter syntax, while the combinations are moved to the dataset. The fact that the parameterization approach allows you to separate scripts from underlying data unlocks more efficiency, accuracy, and scalability. You don't need to replicate the script changes from test to test. You can more easily add or remove scenarios at the dataset level, and all that lowers the chances of outdated or erroneous tests being executed. With that said, it is also important to consider the challenges of parameterized tests. Most of them stem from other DDT stages. Namely, you have to consider execution and reporting limitations while you are designing the script and the dataset. Is the single set of steps truly clear enough to execute all iterations? Can we treat anything dynamic as a parameter? Or should we stay away from things like the operating system or the environment? How can we accurately show the effort to our stakeholders if on the surface there is only one test entity? Those are some of the questions you have to discuss before committing to this technique. Next, selective re-execution is a little bit trickier. For instance, when you want to repeat only the failed iterations, it is helpful if your execution tool can handle the scope identification by the row ID of the data source. Another possible solution could be to temporarily subset the data source and reassign it. Lastly, while maintenance is more efficient overall, it does take a bit of a learning curve to avoid the synchronization between the script and the dataset. So, how do we make parameterization happen in Xray? First, let's talk about the script editing. Parameter syntax can be added in these different spots throughout the script, providing the flexibility needed for more complex and conditional flows. Parameter names are case-sensitive, have a maximum of 64 characters, must start with a letter or underscore, and have certain other restrictions that you can check in the documentation or just ask the NUCIDA Xray experts. While you can insert parameters into individual tests directly, there is also a more reusable approach. It is highlighted in levels 2 and 3 on this slide. The menu option in Xray settings is called Parameter Value Lists. The choice between project and global levels depends on your configuration and preferences. If you have, for instance, only one dedicated testing project, sticking to its settings makes sense. If you have multiple testing projects that work with related scopes, global settings for the common reusable parameters will save you more time and improve consistency. Now, the second part, as we discussed, datasets store all the iterations to feed the parameters. Xray allows you to create datasets in 3 ways: manual specification, combinatorial generation, and import. Seeding parameters correspond to the first method. They allow you to pick each value independently and build the scenarios however you would like. On the other hand, marking parameters as combinatorial tells Xray to generate all possible interactions for you. It is always possible to convert back and forth between parameter types, and you can have a mix of them in the same dataset, regardless of the creation method. You can apply adjustments like changing cell values, adding or removing rows, etc. at any point. And last but not least, you need to keep these capacity limitations in mind. One more important aspect before jumping into the demo, the Xray hierarchy of processing datasets. In short, the closer you are to the execution layer, the higher the dataset priority is. Leveraging multiple layers at the same time is not very common, but keeping this logic in mind helps avoid surprises. For instance, you edit the dataset at the test level, but accidentally keep the old one at the test plan level, and then outdated values appear in the next execution. On that note, just for the avoidance of doubt, to reuse the exact same data set across entities, you need to either export, then re-import, or recreate it. It's time to see this Xray feature in action. Here we have a test issue for card checkout validations. It's not critical whether you tackle the dataset or the script. First, we will begin with the dataset. Based on the admittedly brief issue description and our domain expertise, we will be adding a few sitting and combinatorial parameters. We will start by pulling several of them from the project list, since those variables are common in the e-commerce scope, namely the browser, the payment method, and the product category. Next, we add quantity, total amount, and gift directly to this dataset. For both quantity and total amount, we will stick to the text type of parameter. This would allow us to have a little bit more freedom when defining specific values. We will mark the browser and payment method as combinatorial, and we will confirm that all their values are relevant for our current scope. Lastly, we will leave the rest 4 parameters as seeding and determining their scenarios manually. We will try to vary them at least a little bit, but will not focus too much on applying advanced design techniques. Your resulting dataset could look like this. It is important to pay attention to the count preview at the top. The math behind this number 80 is the number of combinatorial interactions, which in our case is 4 times 5 equals 20, and then times the number of seeding rows. So that is 20 times 4, which results in 80 Xray, will generate the complete view of all iterations automatically upon execution, or you can trigger it from the menu for either of the combinatorial parameters here. Now let's save and bring the script up to speed. We already have static elements in action data and expected results simplified for demo purposes. So, the only thing that's missing is the parameterized syntax to tie our script and dataset together. The benefit of doing the dataset first is that we enable autocomplete selection, as you can see here. You can do it by typing the $ and the opening bracket, or it is also available from the drop-down. As a reminder, you can leverage the same parameters in different fields of the step, so you can match the action and the validation, or the expected result, easily. As we complete this parameterization step, we reread our script and notice that there is one more potential parameter that we missed in the initial dataset creation. Here, promotion application is dynamic and dependent on the product category plus gift status. We add the parameter to the script first and notice a different highlight. As you can see, the new parameter is in red. That means the variable is not defined in the dataset. We fix that by going back to our iterations table and appending promotion as a ceiling parameter. The last important task that we will have to do manually here is to select the right value of that promotion parameter based on how the product category and gift behave in a given row. Let's imagine that the actual rule is that promotion is only applied when the product category is either A or C, and the gift is checked. So, in our case, only the first row would match that criterion, which means we set the other three to not applied and save. We will notice that our promotion parameter turned into the blue color, which means that it is recognized in the dataset. It is also worth highlighting a couple of dependencies between the script and the dataset. Deleting a parameter from a dataset will not remove it from the test case. It just becomes red and undefined. Changing a parameter name on a dataset will not automatically change its name on the test case and will not create iterations when executing the test, because the parameter would be treated as unknown. As an extra exercise, and let's assume we are moving towards automation and are exploring the cucumber type of tests. With Xray Enterprise, we can leverage test case versioning and choose to copy from our baseline manual 1. The benefit is that we don't have to create a separate Jira issue, or another Xray test, so to speak, and we get to carry over the dataset we just created. Now, we can just switch the test type to cucumber and leverage the same parameterized approach. Just note the syntax difference when you're referring to a given parameter. This concludes the Xray portion of the demo. We are set up with our first parameterized test. We've avoided the proliferation of test issues and improved efficiency. This feature has been working well for Xray users, but that doesn't mean we cannot improve it even further. In our example, we had a combinatorial parameters browser with 4 values and 5 payment methods, along with 4 seating rows. Thus, we got 80 iterations. Imagine we add a new combinatorial parameter with just 2 values. We will get 160 iterations, which is an all-or-nothing kind of situation. Furthermore, what if not all combinations are valid? Manual, one-by-one removal of impossible scenarios is not super scalable. That's where the Test Case Designer, or TCD, comes in. As a quick summary, it is a specialized model-based test design optimization tool. The goal is to enhance both the speed and the quality of test case creation, allowing you to find more defects more efficiently. Typically, a user would analyze the requirements in Jira, create the model inside TCD, then move the scripted tests to either Xray or the automation framework for execution, and Xray remains the source of truth for consolidated results. Engage in TCD early in the sprint process with the artifacts, like mind maps, which help increase coverage and avoid ambiguities up front. However, the tool is pretty versatile, connectivity-wise, so different workflows are possible, albeit less common. I will focus on one of those in our second demo. Before diving in, I want to highlight 3 key differentiators of Test Case Designer when compared to Xray's parameterized tests. First, advanced rule handling helps. You make sure the tests are always valid, based on your scope and business logic. Second, the Test Case Designer uses an intelligent augmentation algorithm with flexible options. including risk-based, so that you can quickly and programmatically adjust the number of scenarios based on the desired level of thoroughness. And last but not least, insightful visualizations enable you to better communicate ideas and make informed decisions about how much testing is enough. Now, I will let the TCD algorithm generate the optimized data table, then export it as a CSV file without involving scripts, and lastly, import it into an Xray test. Besides building parameters and values in TCD, I can also use the optional forced interactions import approach because we have already established the dataset with our 80 iterations in Xray. This rather unconventional starting point can accelerate the process. I just need to format it based on TCD import requirements. You can see our combinations saved on this screen in TCD, which 1. Automatically builds out parameters and values on the first screen, and 2. Informs the algorithm that these scenarios should be included in the data table as the initial rouse. As another optional step, but often useful on the analysis screen, we can check our interaction coverage percentage so far. Moving the slider to match the number of iterations imported from Xray, we can notice that all pairs between browser and payment method are green, as expected. But the rest could be improved since we just created those 4 seeding rows manually, without giving it as much thought as we could have. For this example, we will not keep imported tests. We will instead give the TCD algorithm the freedom to perform fresh generation. But before we do that, let's quickly double-check that our parameter screen is in good shape. We notice all the parameters and values from our Xray dataset are accounted for. But now, let's see if we can make a couple of improvements. TCD supports number randomization, so we will convert quantity and total amount to ranged values within the boundaries we defined in Xray. The only rule here is that the ranges cannot overlap. Also, you can mix ranged values with individual numbers. So we will leave 5,190 as it was. Also, let's imagine that we learn from our business analysts and subject matter experts that crypto and loyalty points are not used nearly as often as the other payment methods, so they don't deserve separate values. Therefore, we can apply the equivalence class technique and group them under Other. Next, we need to ensure our promotion logic is programmatically handled by the algorithm. To achieve that on the constraint screen, we will add the following expression. When a product category is either A or C, and the gift parameter has the value checked, then, and only then, the promotion status will be applied. Note the double-sided arrow highlighting that this is the only way to achieve a certain result. With these 2 screens completed and optimized, we are ready to regenerate the dataset. We will click on the Scenarios button, and by default, the pairwise option gives us about 23 iterations. The logic is like Xray at a high level, but has a few caveats. Rather than repeat the combination of browser and payment method for each seeding interaction, TCD treats all parameters as combinatorial and then looks at every pair of them based on our algorithm selection, identifies all unconstrained combinations, and lastly, arranges them in as few rows as mathematically feasible. Further, you have more flexibility. Maybe you don't need a thorough test suite, and covering each value once is sufficient, which maps to the one-way setting. Or perhaps you need extra quality and decide that covering every possible triplet is most suitable, which maps to the three-way setting. This provides a variety of middle ground options you can't easily get into Xray. For this example, we will actually select our risk-based approach, and we will set the goal to cover every three-way combination, but only for the parameters involved in the promotion rule. We can quickly regenerate the new data set based on our preferences, and in this case, it won't lead to an increase in the iteration count. We now have the model inside TCD and the optimized data set, which we can download directly from this screen and import back to Xray. Now back to Xray, we will open the dataset menu. We could clear out the whole dataset if we wanted to, but at the very least, we need to ensure there are no combinatorial parameters left. Otherwise, you will be doing the double counting. And then from the import menu, we will select the CSV file with the optimized data table we just got from the test case designer. There are a few important considerations in this dialog. Create new parameters if enabled. We'll add any non-existent parameters automatically based on the CSV column names. Otherwise, it will just append or update the values for the existing parameters and ignore the rest. Speaking of CSV column names, it is important to keep in mind that if there is an asterisk at the end, then the import process for Xray will treat those parameters as combinatorial and then generate extra iterations. You don't need it for this flow. So make sure that on the test case designer side, there are no asterisks in the parameter names. The checkbox Override Existing Parameter Values is useful if requirements have changed in between the dataset edits. And you can see the exact same table with 23 iterations now attached to our Xray test. And a quick side note. If you are leveraging Cucumber outline format in Xray, with the examples table underneath the Gherkin script, you can download the TCD dataset in the pipe delimited format from the same Save As menu and then copy and paste it to the Xray Cucumber test. This concludes with the TCD portion of the demo. We now have a faster and more thorough way to generate datasets for any of our scripting needs, focusing on the design stage. I still wanted to provide a glimpse into how Xray would handle parameterized execution. In the test run view, it will automatically create a subsection per dataset iteration. Parameter values will be inserted into the steps. So, reading each of them will feel no different from traditional test design. And probably the most important part, you can handle execution details such as status evidence or defects at the iteration level. Now, I want to give you a teaser about the upcoming Xray improvements concerning the built-in test executions report that will tackle iteration summaries and details in a more insightful way. In conclusion, data-driven testing can be very useful despite challenges. It is not universally applicable, but especially rule and variation-heavy workflows can reap quite a lot of benefits in both speed and quality. Parameterization is the foundational stage of that technique, so doing it in an optimal and efficient manner is often key. Xray's parameterized tests are a good starting point. Then, TCD takes it a step further. They cover each other's shortcomings and together help you get the most from parameterization and data-driven testing. As a brief recap of usability in this table, Xray's parameterized tests offer more flexible scripting, while TCD provides more robust dataset generation. Test management shouldn't be a burden to your team. That's why over 10 million testers and 10,000 companies in 135 countries worldwide trust Xray to deliver the highest quality products faster than ever before. Break the silo between testing and development. Integrate them under the same tool set with Xray for Jira, and NUCIDA supports you to achieve that. If you like it, please give this video a thumbs up, subscribe to this channel, and click the bell. Never forget our upcoming sessions. If you have any questions or hints, please leave a comment. Our certified QA experts will reply in time, or even produce a separate video about your topic. Please also check out our other over 200 videos about software quality. Happy testing! See you next time.